All right, this is our last section, like I said, in chapter 1. Displaying quantitative data, the last graph that we need to talk about is a box plot, and we need to talk about how to determine whether points are outliers or not. So the first thing we're going to look at is how to identify outliers. Up until now, outliers have been a judgment call. Yeah, that looks like it's far away, so we're going to call that an outlier. But we actually have outlier rules. The outlier rules are if the data point is more than 1.5 IQRs from the quartiles, then it's an outlier. So we create what are called fences. We put these fences up, and if the points are outside the fences, they are outliers. Our lower fence is Q1, the first quartile, minus 1.5 times the IQR. Any values lower than the lower fence are outliers. The upper fence is Q3 plus 1.5 times the IQR. Values that are greater than our upper fence are outliers. All right, here is our first example. I just pulled these out of the book, obviously. Here's the data on the average number of points per game that LeBron James has scored on each of his first 16 NBA seasons. Now, if you're copying this in your notes, which you should be, don't write everything down. Write average number of points per game, LeBron James. And then write the numbers down, and I suggest when you write them down, you write them in order, from smallest to largest. That will help us find the outliers. So in order to find the outliers, we have to find our 5-number summary and our IQR. No, we're going to find it by hand. It's good practice. So find your median first. We have to find our median, so then we can find our quartiles. So go ahead and find your median and your quartile 1 and quartile 3. 16 numbers. The median is going to be the halfway point. If there's 16 numbers, that's going to be between the 8th and 9th number, right? So if we count it out, it's between 27.1 and 27.2. So that means the median is 27.15. You can add them together and divide by 2. Make sure in your calculator you add them together and hit enter before you hit divide by 2. Otherwise it divides it and then adds the first number. Uses the order of operations. Now to find the first quartile, I want the middle of the bottom half. So there's 8 values here, right? So quartile 1 is going to be the middle of the 8. Where is that going to be? Between the 4th and 5th value, right? So 1, 2, 3, 4. My median is going to be here, between 26.4 and 26.7. Yes. And so 26.55 is my quartile 1. Why? You have to include the 27.1 when I'm counting because it's not the median. The median's between these two. So you still have to use the 27.1 because it's not the actual median. And then in between 1, 2, 3, 4, 27.5 and 28.4 is your Q3. So 27.5 plus 28.4 divided by 2 is 27.95, which is my Q3. Then I can calculate my IQR. So I need the IQR to find the outliers, the outlier fences. So 27.95 minus 26.55 is 1.4. Okay, did we get all that? Okay, then we plug it into our equations. The lower fence, we'll just abbreviate LF, is Q1 minus 1.5 times the IQR, which is 26.55 minus 1.5 times the IQR of 1.4.
What is LF?
Lower fence. So 26.55 minus 2.1 is 24.45. Then my upper fence is the Q3, right? Now I want to know what's 1.5 quartiles above the third quartile, or 1.5 IQRs above the third quartile. So Q3 plus 1.5 times the IQR, which is 27.95 plus 1.5 times 1.4, 27.95 plus 2.1, 30.05. So these fences, everything that's not an outlier will be inside the fence. Everything that is an outlier is outside the fence. So lower than 24.95, are there outliers? So yes, 20.9 is an outlier because it is less than the lower fence. And are there upper outliers? How many? 1. 30 is not greater than 30.05, right? So 31.4 is an outlier because it is greater than the upper fence. Here's your next example. In a recent year, Consumer Reports rated many tablet computers for overall performance and quality. One variable measured was the depth thickness of each tablet in inches. The depths of 23 tablets in inches produced by Samsung are below. Are there any outliers? Okay, so your job right now is to do this problem in your notes. Put them in order. Find your median, find your quartiles so that you can find your IQR, and then determine if there are any outliers. Remember, you don't have to write all the words down either, right? Yeah. 23. Okay, so one of the ways you could organize your data is by making a quick dot plot, right? My numbers go from 0.27 to 0.48. So if I make a quick dot plot, that'll give me, I have a 3.2, 3.3, or 0.3, 0.3, 0.33, 0.27, 0.31, 0.34, 0.32, 0.39, 0.33, I just did that one, 0.48, 0.38, 0.37, and 2.39s. So now I have a dot plot. I don't have a list of the numbers in order, but can I find which dot would be the middle dot? There are 23 dots, right? Which dot's going to be in the middle? What's the middle of 23? 12. Yes. 23 divided by 2 is 11 and a half. When it's half, you round up, so that's the 12th number. All right, we have 23 values. We organize them into a dot plot. Half of 23 is 11 and a half, right? 11.5. Which means the middle value is the 12th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is my median. So my median, guys, my median is 0.33, right? Now I can choose to include it or not. If I include the median, then my lower half has 12 values. So better to not include it so it's odd, right? When it's odd, I can just circle a number. I don't have to do any averaging. So what's halfway in 11 numbers? Sixth number, right? Half of 11 is 5.5. Since that didn't come out evenly, we round up. So find the sixth number. 1, 2, 3, 4, 5, 6. So my Q1 is 0.32. And then I have to count from here above the median. Same numbers, same amount. 1, 2, 3, 4, 5, 6. So it's 0.38. So Q3, 0.38. Okay. So it may not have changed adding in the points that I had missed. That makes my IQR what? 0.06. Yes.
Why?
Because 0.38 minus 0.32 is 0.06. Then, did you calculate your fences? Q1, 0.32 minus 1.5 times 0.06. 1.5 times 0.06. No, 1.5 times 0.06 is 0.09. So 0.32 minus 0.09 is going to be 0.23. This is your lower fence. 0.38 plus 0.09. Okay, the reason I do this calculation and not just plug it all in my calculator is so when I do the upper fence, I can just take that 0.09. So 0.38 plus 0.09 is 0.47. That's my upper fence. So here's a good picture as to where your fences are. 0.47 is a fence, and 0.23 is a fence. Do I have anything anything lying outside? Outliers. What? 0.48. So 0.48 is an outlier. So hopefully that the being on the graph and a number line kind of helps us visualize that fence idea, right? So if it's outside those fences, it's an outlier. We have that point at 0.48. Okay, so dot plots can be used, so can stem and leaf displays, to organize the data in order without having to write all the numbers and then you miss one like we did on the last one. And you can still use the dots to find your 5-number summary. Outliers are important to identify for several different reasons. One, they may be an inaccurate data value. Maybe somebody entered 10.1 as 101. Or maybe you entered 5 instead of 50 because you thought you hit the 0 when you were putting the data in your calculator. Maybe someone was being silly when they were answering your survey and they just gave you a number that's totally ridiculous. They can indicate something remarkable. If you were looking at a graph of career earnings, Tiger Woods would likely be an outlier. And they can indicate the values, or they can influence the values of some summary statistics. The median and the IQR are resistant to outliers, but the mean and the standard deviation and the range are not resistant. So they can be influenced, so it's important a lot of the times to look at the data with and without the outliers. Box plots are another way to graph quantitative data. We've done a dot plot, a stem plot, a histogram, and a box plot. Box plot shows the distribution of the quantitative data as the 5-number summary. It's a visual representation of that, the minimum, the Q1, the median, the Q3, and the maximum. I'm going to kind of darken this line here. Tried to figure out how to make it darker, but it wouldn't do it for me. So the box, part of the box plot, is your IQR. The middle 50% of the data. It shows you visually how spread out it is. The line that you see in the middle of the box is the median. The line in the middle of the box is your median, and the box represents your IQR. So if you're comparing two box plots without any numbers, you can compare the IQR by looking at the size of the boxes, and you can compare the medians to see which one's higher and which one's lower.
So between Q1 and Q3,
3,
line is the median.
the line is the median, yes.
The line that goes up and down.
Correct, in the middle of the box.
And then Q1 is that line.
Q1 is the beginning of the box, and Q3 is the end of the box.
And then the IQR is the blue.
Correct, the IQR is all the blue.
Okay. Should I write it in different colors?
It's up to you. Now, it normally sits on top of some kind of number line. It like hovers over a number line. We're going to make box plots out of the data. Okay, so look back in your notes from yesterday. Didn't we get the 5-number summary for this? We definitely calculated the IQR, so we had to know the quartiles, right? So what was our minimum? I believe that's the 20.9, right? You put them in order yesterday. Go back and look in your notes and let me know. The Q1 was what? 26.55. The median was
27.15.
and the Q3
27.95.
and the max. The max is 31.4. Okay, so we got that data. We did the quartiles and the median earlier in the notes, so we'll just use those again. And then identifying the minimum and the maximum. Now, we identified outliers, right? Was there an outlier?
Yeah.
The fence was 20.9?
No,
Or 20.9 was an outlier?
20.9 was the outlier because it was less than the lower fence.
Okay. And then wasn't 31.4 also an outlier?
30.05 was the outlier because it was greater than the upper fence.
Right. So 30.05 was our fence.
Oh, it's
So
31.4.
31.4 was the outlier. So what that means, since I have two outliers, is we're going to find the next data value and use that as the minimum in our graph. Okay, so what was the next data value after 20.9? 25.3. And then we had the 30.0 was the next second highest number line or value. So we're going to draw a number line. I'm going to draw it big and then we'll see what we need. I'm going to start it at 20. I actually don't need it to be that small. Hold on. Since we have decimals, I'm going to mark that halfway point so we can draw a more accurate graph. My minimum is 20.9, so I'm going to start my number line at 20, and my maximum is 31.4. That's 31, and here's 31.5. Okay. So my outliers. Okay, so we start with our outlier. Our outlier is 20.9. So instead of putting that little hash line for minimum, we're going to put an asterisk or a star. We have an outlier at 20.9. We have an outlier at 31.4. Those are our ultimate minimums and maximums, but we're going to bring the box plot into the next highest data value that is not an outlier, which was 30. 30 was not an outlier, so that's going to be the maximum bar for my my box plot. And then my Q3, I draw the bigger bar, the beginning of the box. It's 27.95. Actually, could go closer to 28. And I connect that. Now I can draw it whichever, I can start with minimum too if I wanted. The median is 27.15. So I draw that line. And then Q1 is 26.55. So there is my box. Okay, so I drew bigger lines at the Q1, the median, and the Q3, and I make a box out of them. Then the highest data value that's not an outlier becomes the maximum. And then the highest data value that's not an outlier becomes the minimum, 25.3. Sorry. 25.3 about here, and then we draw that whisker. And there's our box plot. Without the outliers, it's a good way to look at the data without the outliers. Without the outliers, that's a pretty symmetric box plot. When you're looking at a box plot, if the box, like the line in the box is in the middle and the whiskers, those are the outside pieces, are the same distance or about the same length, it's pretty symmetric. Whichever one is longer, that's where the skew is. So with the outliers, this data is skewed in which direction? No, this outlier definitely causes it to skew to the left because of the small outlier, right? Okay, so this is the data that we used on the tablets. The minimum was 0.27. What was Q1? 0.33. The median was also the median was 0.33. What was Q1? 0.32. The Q3 was, and the max was 0.48. And was there an outlier? 0.48 was considered an outlier. So what was the next data value below that outlier? Okay, so we're going to use 0.39 is our max for the box plot.
Wait, why are you using 0.3?
Okay, so 0.48 was our outlier. The data value before the outlier that's not an outlier is 0.39. We can have more than one outlier. It's possible to have more than one or several dots on your box plot that represent outliers. So can you draw this box plot? What's our number line going to go from? To 0.48. I want it right. What is that? That's weird. I've never had it do that before.
Wait, are we doing from 27 to 48?
Yeah, 0.27 to 8 to 9.30. No, you're not going to skip. It has to be a number line. Okay, I mean you can skip labeling. You don't have to label every single number. But it has to be a number line.
From 27
Yeah.
to 48?
I just need to represent all the numbers between 0.27 and 0.48. Okay, I can't just make a number line and put my 5 numbers on it. I need to show how spaced out those numbers are by making my number line accurate. So it needs to be from 0.27 to 0.48, and it has to have all the numbers in between. Okay, I'm going to give you a second to draw this one. Let's see, what our minimum, okay, we can draw it either way. Our minimum is at 27.27. Our Q1 is at 32, so we draw a bigger line. Our median is 33. Our Q3 is 38.
Why is this one so big? The other one isn't big.
I don't know. You mean like tall?
Just, yeah, like tall. Like, is it,
I have space. I mean, it doesn't matter how tall your box is.
like, why? Why is it so big?
And I'm also drawing it so you can see it really well too. So, and then my max line is going to go at 39, and then out here at 48.48 is going to be our outlier. Okay. So your graph should look a lot like mine. Does it?
Yes.
Wait, the outlier is. Wait, what's the.
This line?
Yeah.
That's the maximum line. It's the maximum point that's not an outlier. So this is a little line. And this line is short because it's really close to the Q3. That's what the lines are telling us. These are telling us how close they are to the Q3.
So 39.
I don't like this one.
Yeah.
So what is skewed to the left?
I would say skewed to the right. Well, because of the outlier. And think about the distance from the median to the minimum and the distance from the median to the maximum. Right? So this distance is much longer, so we're skewed to the right.
So the line.
Guys, you need to quiet down. I can't hear her question. Diego, shh, you guys. Right, we can't just look at these lines because they represent the lowest 25% and the highest 25%. So we want to really look from the median to the max and from the median to the min. And so here our data would be skewed right. Okay. Now, then, like I said, when you take out the outlier, it changes the shape. Okay, you take out the outlier, that distance difference, and then if we look at our dot plot, how would we have described the dot plot as well? We want to know who is actually the greatest of all time in basketball. The debate is that LeBron James is better than Michael Jordan. Okay, so let's look at their average points scored per game by each player in the seasons they played through 2019. So they must have written the book in 2019, right? Because they don't have data after that yet. It's giving us the numerical summaries, okay? So here's our 5-number summary. LeBron James averaged 27.16 points, and Michael Jordan averaged 29.4 points, 4.5 points. Michael Jordan's standard deviation is higher, right? Remember, that means on average his points per game varied from the mean 4.6 points, okay? Yes, I want you to do it by hand. Then I'll show you how to do the calculator later.
Why do you want to filter it?
Because on a lot of tests, you're going to be required to do a lot of this by hand. Statistics teachers in college tend to be very old school. So they want you to know how to draw it by hand, right? So, yeah, but that's what I'm preparing you for. Okay, so when you go in, it'll be an easy A. That's my goal. When we're drawing comparative box plots, we draw one number line that consists of all of the data we need, and then we stack the 2 box plots on top of each other, like hovering on top of each other. Okay, so our number line is going to look a lot like the one we used for the slide 2 times ago, right? The minimum is 20. The maximum is 37.1. We will need to recalculate. You'll need to calculate outliers for Michael Jordan. Actually, let's be smart about this. Yeah, don't worry about it.
I mean, we calculated the fences.
Okay, so let's talk about the fences and outliers. I had to extend the number line to 37 because Jordan's max is 37.1. Calculate the outliers. The upper fence was 41.15, right? That was 32.6 plus 1.5 times the IQR for 5.7. And then the lower fence was 18.35.
Wait, if his max is 37, wouldn't that make the X?
What?
Not the exponent, what is it?
No, because it's lower than my fence. Remember that it has to be bigger than the fence, the upper fence, to be an outlier. So his max is 37.1, which is less than the fence. Right? We have fences. They're over here at 18 and 41. Everything's in that fence, so we're okay. We don't have any outliers for Jordan.
Right, if I say yes, it takes the grade and just.
So, what can we say about the difference in their seasons? Bigger how? What about it is bigger? The range, right? Jordan has a higher range of values, right? His is from 37.1 to 20, so it's 17. And LeBron's is only about 11, right? Max minus min, that's range. So Jordan has a much bigger spread, right? His average per game for his seasons had more variability than LeBron. LeBron was more consistent, right? If we take out his outliers, he was pretty much within 5-point average every season. That's consistency, right? That's talking about the spread, the variability. Now let's talk about comparing quartiles and stuff. Remember, quarter means 4, right? We're dividing the data, 100% of the data, into 4 pieces. So each piece of your box plot represents 25% of the data. 25% from the min to Q1, 25% from the Q1 to the median, 25% from the median to the Q3, and 25% from Q3 to the max. What do you notice about comparing Jordan's graph to James's graph? Pick one of the 5 number summary values and compare it to something that's below it. For example, the median. Jordan's median is bigger than James's maximum. 50% of the seasons, Jordan scored an average points per game more than LeBron's maximum season. Now, look at this. The Q1 is close to Jordan's Q1, right? Their lower 25% are pretty close together. But Jordan's best 50% of seasons was still better than James's best season. Is the case closed? Yeah, Jordan's the GOAT, right? Jordan's the GOAT. So when we are comparing box plots, we want to look at things like that. We want to look at how the median is bigger than that maximum, or that Q3 is bigger than his outlier. Jordan's Q3 is bigger than James's outlier, so 25% of his seasons are bigger than that outlier. So when we're comparing, it's important to look at those different measures and make statements about 50% of the time, 25% of the time, Jordan was better than James's outlier. Okay? So those are things we want to talk about when we're comparing box plots.